Lesson 5-7, Solving Equations by Adding or Subtracting Fractions. Now, we have solved equations before with adding and subtracting. This is our first time solving equations with fractions. So we're going to use a little bit of what we've learned about adding and subtracting fractions, but we're going to add an equation. Here we go. So using subtraction to solve an equation. You can solve equations with fractions the same way you would solve a normal equation with integers and decimals, by using those inverse operations. Let's review what that was. If I had 3 plus n equals 5, right now I want to solve so I have n all by itself. But if you look here, it's attached to a 3 with addition. To undo, that's our kind of our key word with inverse operations, to undo addition, I'm going to subtract that 3. What I do to one side, remember I always do to the other. So my 3's are going to cancel. I'm left with just my n. 5 minus 3 on the other side is going to leave me with 2. N equals 2. That is solving an equation using subtraction. Now, in our lesson today, it's the same thing, still an equation, still needing to add or subtract to undo an operation. However, we have fractions. So, just like in this problem, let me get a new color, we subtracted the 3. This n is attached to 3/10 with addition. So I'm going to undo that addition by subtracting 3/10 from this side and subtracting 3/10 from this side. Now we have a problem that we've been working on so far, 1/3 minus 3/10. Well, we know, I'm going to rewrite this, we can't add or subtract fractions unless they look alike. So I'm going to find a common multiple of 3 and 10. Let's use 30. 3 times 10 gives me 30, so 1 times 10. 10 times 3 gives me 30, so 3 times 3. Now, my answer is going to have the same denominator. I just subtract the top numbers. 10 minus 9 is 1/30. All right, let's do one more problem together. Y plus 8/9 equals 5/9. I want y all by itself. To undo this addition, I'm going to subtract 8/9. What I do to one side, do to the other. This cancels out. I'm left with just my y. And I have a subtraction problem with fractions. Let me transfer that over here. I need a little more room to write. 5/9 minus 8/9. Luckily, my denominators are the same. So my answer will be over 9. 5 minus 8 is a -3. This can simplify, always simplify your fractions, to -1/3. All right, in example 2, we are using addition to solve equations. So now, instead of undoing addition, we're going to undo this subtraction sign. Solve n minus 3/4 equals -5/8. To get n by itself, I'm going to add 3/4. Do it to both sides. -3/4 and +3/4 cancels out on this side. I'm left with just my n. N equals, let me rewrite what's over here, 5/8 plus 3/4. I can't add these quite yet because they have different denominators. So I'm going to write them both with the denominator of 8 because I know 4 also goes into 8. So this one stays. This one over 8, 4 times 2 gives me 8. 3 times 2 gives me 6. Add that up over 8 is 11. N equals 11/8. Some of you like to make that a mixed number. I could do 1 and 3/8. All right, one more example for you to watch. 6/7 equals x minus 2/7. Right now, I want x by itself. I'm going to undo that subtraction by adding 2/7, adding 2/7. Luckily, I have the same denominator. This is a quick problem. 6 then plus 2 is 8/7 equals my x, because this canceled out on that side. X equals 8/7. Again, mixed number would work as well. Last example. Just like in the past lessons of Chapter 5, we've been dealing with a mixed number. Still solving an equation, and we're still going to, well, we can solve this in two ways. Let me read the problem. Henry cut 1 3/8 yards from a piece of wood. Afterward, it was 2 1/4 yards long. The equation P minus 1 3/8 equals 2 1/4 models this situation. How long was the piece of wood before Henry cut it? Basically, we need to solve for P. We can do it two ways. One, we could make the mixed numbers into improper fractions, or method 2, we could make the mixed numbers decimals. I'm going to show you both. So here, P minus 1 3/8. To undo the subtraction, we're going to add the 1 3/8 over here as well. So I have, this cancels. I'm left with P equals 2 1/4 plus 1 3/8. Now I'm going to make those improper fractions. 4 times 2 is 8 plus 1 is 9/4. 8 times 1 is 8 plus 3 is 11/8. I need to make these look alike, so I will make this fraction over 8ths. 4 times 2, 9 times 2. So I'm now looking at 18/8 plus 11/8. That's going to be 29/8. In method 2, you're doing the same thing, except we converted 1 3/8 to its decimal form, 2 1/4 to its decimal form. So now I'm going to just add to both sides. And P equals 3.625. All right. So we'll just do one more example, looking at this mixed number equation right here. 3 7/8 equals z plus 1 1/3. I'm going to rewrite the whole problem using improper fractions. To do that, I do 8 times 3 plus 7. 8 times 3 is 24, plus 7 is 31/8, equals, this is the letter z, plus 3 times 1 plus 1. 3 times 1 is 3, plus 1 is 4/3. All right, I have my improper fractions. Now I'm going to undo the addition by subtracting 4/3 to both sides. I'm left with z. I'm going to rewrite my subtraction problem here so I can see it better. 31/8 minus 4/3. A common denominator for these fractions, let's use 24. 8 times 3 to get to 24. 31 times 3, 93. 3 times 8, 4 times 8 is 32. Do the subtraction, my answer will be over 24, the same denominator. I need to do 93 minus 32, 61/24 equals z. Now it's your turn. I would like you to solve these 3 problems. They will be turned into me. If you need to pause the screen, I recommend you do so now and copy down the problem so you can solve them. We will talk about them in class.